Hi, today we are going to do lesson 6.3, applying linear functions. A car dealership has 40 cars in stock. The auto manufacturer will deliver new cars to the dealership by car carrier. Each carrier holds 6 cars. Write a linear function that relates the number of car carriers used to the total number of cars at the dealership. Graph the function. So we have the total number of cars at the dealership equals 40, because that's how many we already have, plus 6 times the number of car carriers, because there are 6 cars on each carrier. Okay, so let's make that an equation. Total number of cars at the dealership is going to be our y, and our number of car carriers is going to be our x, because this controls this, right? Okay, so we have y equals 40 plus 6 times x. Now let's put it in slope-intercept form, which means your x term goes before your constant. Y equals 6x plus 40. At this point, we can go ahead and graph because we have our y-intercept and we have our slope. Okay, I'm going to count by tens going up. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. All the way up to 180. That's a 0 right there. Okay, going across, I'm going to go ahead and count by ones. So that'd be 2, 4, 6, 8, 10, 12, 14, 16, and 18. Okay? Now my y-intercept is 40, so I'll go up to 40, and I make my mark. My slope is 6, which is 6 over 1. So I go up 6 over 1. Okay? That's going to be right there, approximately. I go up 6 more, which gets me to 12 over 1. I go up 6 more, which gets me to 18 over 1. Up 1 more, which gets me to 24 over 1. Up 1 more, which gets me up 30 over 1. Now this point is the easiest one because it was up 30, 10, 20, 30, and it was over 5. Okay, that was the easiest one. The next one is going to be up 30 more and over 5 more, right? 1, 2, 3. 1, 2, 3. That's going to be the next obvious point. But there's a point in between on each of these lines. Okay? And we're not going to color that in with a line because you can't have a half a car. Or if you do, you won't get very far. Okay, a sporting goods store sells cans of tennis balls. There are 3 tennis balls in each can. The coach of the tennis team is buying supplies. Write a linear function that relates the number of cans to the total number of tennis balls. So we have the total number is 3 times the number of cans. Okay, so y equals 3x. Okay, now graphing this one, I'm going to go ahead and I can just count by ones, but I will label every other one so it doesn't get too crowded. So 2 more, 4, 6, 8, 10, 12. And then the same thing over here, 2, 4, 6, 8, 10, 12. Okay, so we're going to start at 0. If we don't buy any cans, we have no tennis balls, right? Okay. And our slope is 3. I go up 3 over 1. up 3 over 1, up 3 over 1, up 3 over 1, and so on. Now, I'm not drawing a line on this one either, because even though you can have 4 tennis balls and 5 tennis balls, you can have 7 tennis balls and 8 tennis balls, you can't buy a part of a can. So you buy 1 can or 2 cans or 3 cans or 4 cans or 5 cans. So again, we just have the dots. Okay, students in a 9th grade class, draw the following graph. So we have a graph here to represent how much money would be in the class fund after washing cars at a fundraiser. Okay? And the questions are, what does the slope and the y-intercept of the graph mean for the given situation? Let's talk about the y-intercept first. What does the y-intercept mean? The y-intercept is right there. Okay? That's our starting point, which means they already had that much money. That should be a D. I don't know what. Let's try that again. Already had. There we go. Now the slope, you go up a certain amount and over a certain amount, up a certain amount and over a certain amount. Each time we're going over 1. Okay? I think that the slope here is how much it goes up for every car, right? So the slope is the cost of the car wash, right? Okay, if the graph had the same slope, but a y-intercept of 14 instead of 25, it looks like, then what could you conclude about the fundraiser? Well, that means that they started with only $14. If the graph had a slope of 5, looks like it's about 450, then what could you conclude? You could conclude that they charged $5 per car. So you can get that information from the graph. Okay, suppose you drew this graph to represent how far you ride your bike at a steady rate. Okay? When you haven't ridden at all, you haven't gone any distance, right? Okay? So here's the time, and here's your distance, and you're traveling at a steady rate. That's why this line is straight. If the graph had a slope of 10, what would that mean? That would mean it would go up 10 and over 1. Distance over time. So that would be 10 miles per hour. Okay? Oh, we forgot we didn't even answer this question. I'm so sorry. What is our rate? Well, when we go up 12, it finally crosses at a line. Here it crosses at a line, here it crosses at a line, but it's not so clear what that value is. And the one that matters is 1, right? Because we want to know miles per hour. So it's 12 miles per hour.